Hi Guy, I'm Laurie from AI Elephant.
Hi guys, I'm Leo.
We often marvel at how powerful AI models have become. You hear about 1 million token context windows and think, wow, this thing can remember a whole library. But have you ever noticed that when you talk to an AI for too long, or give it a complex task, it actually starts getting, well, a bit dumb?
Oh, absolutely. It feels like they hit a wall. I had a session the other day where the AI just started looping, repeating itself, or totally forgetting the instructions I gave it 10 minutes ago. I thought these things were supposed to have super brains. Do they get tired?
In a way, yes. It is a phenomenon called context rot. And today, we are diving deep into how top engineers are fixing this. We're exploring the art of context engineering, how to cure AI of its amnesia, and keep it sharp, even during the longest missions. So, let us start with a counter. Intuitive fact from the recent LangChain and Manus webinar. We assume a bigger context window, like 200,000 or 1 million tokens, solves everything. But actually, it leads to something called context explosion.
Explosion? That sounds dramatic. Is it just because we feed it too much data?
It is not just what TWA we feed it. It is what the Thurvey agent TWA generates. When an autonomous AI uses tools searching the web, running code, reading files, it creates massive amounts of logs, error messages, and raw HTML. This junk fills up the memory fast.
Right, it is. Like when I'm working on a project and my desk gets covered in sticky notes, coffee cups, and printouts until I can't find my laptop anymore.
Exactly. The chief scientist at Manus, Peak, points out that long before a model hits its hard limit, it suffers from context rot. It gets confused by the noise. So, the goal of context engineering isn't just to make the window bigger. It is to ensure the window is filled with only the right information. To manage this clutter, Manus uses two distinct strategies: compaction and summarization. Now, Leo, these sound similar, but they are fundamentally different.
I'm guessing one is just shortening text and the other is rewriting it.
Close, but the key difference is reversibility. Compaction is reversible. Imagine the AI writes a huge block of text to a file. In compaction mode, the system removes that long text from the chat history, but keeps the 20-file pathy.
I see. So it is like saving a shortcut on my desktop instead of keeping the whole file open.
Precisely, the AI knows the file exists. If it needs the details 10 steps later, it can use a tool to read it back. That is crucial because you never know what minor detail might be important later. You don't want to lose it permanently.
Okay, so that is compaction. Then when do we use summarization?
Summarization is the last resort. It is irreversible. When the memory is about to burst, you force the AI to summarize what happened. But, and this is key, you don't just say summarize this. You use a structured form or schema. You make the AI fill in specific fields. What was the user's goal? What files did I change? This prevents the AI from hallucinating or writing a poetic but useless summary. Now, that is how a single agent manages its own brain. But complex tasks often require multiple agents. This introduces context isolation. Think of it as, how much do you tell your coworkers?
Well, that depends. Am I dumping a task on an intern or brainstorming with a partner?
That is the perfect analogy. Method 1 is communication by instruction. You give a subagent a clear, short task, find this code snippet. The subagent sees fin nothing, quan of the past history. It just does the job and leaves. It is cheap and fast.
Okay, fire and forget. What is the other method?
Method 2 is shared context. This is for deep research. The subagent gets to read the entire chat history, all the notes, everything. It is like bringing a partner up to speed on a year-long project.
That sounds expensive. If they have to read everything, doesn't that burn through tokens?
It is very expensive. It kills the cache and costs money. So, a huge part of context engineering is deciding, do I just need a task done intern, or do I need deep understanding partner? There's one more layer here that I found fascinating.
It turns out, even giving an AI a list of tools takes up too much memory. So, Manus created a layered action space.
Wait, so even the instruction manual for the tools is too heavy to carry.
Exactly. So they split it. Level 1, atomic functions. Basic stuff like read, write, click. Level 2, the sandbox. This is brilliant. Instead of the AI reading a massive file into its context window to find one word, it runs a Linux command like footy grep sandbox.
Oh, so instead of reading the book, it uses a search engine.
Right. It offloads the computation to the system. It keeps the context clean. And level 3 involves writing Python scripts to use complex APIs. By doing this, the AI doesn't need to memorize how every tool works, it just needs to know how to code. We've covered a lot of technical ground, but the philosophy behind it is what matters. Peake, the scientist from Manus, said the goal isn't to build the most complex system possible, it is to trust the model.
Trust the model? Even when they get confused?
Yes, we should build architectures that are simple and resilient, because today's dumb model is tomorrow's genius. If we over-engineer crazy tricks now, they might become obsolete when the next GPT or Claude drops. So, here are the 3 takeaways for anyone building with AI. 1. Prioritize compaction over summarization. Keep data reversible as long as possible. 2. Offload. Don't upload. Use external tools and sandboxes rather than stuffing everything into the chat. 3. Keep it simple. Don't over. Engineer, let the model do the heavy lifting.
I love that. It is not about giving the AI a bigger brain, it is about giving it a cleaner desk. Thanks for breaking that down, Laurie. I feel like my own context window just got a bit clearer.
Glad to hear it. Thanks for listening, everyone. See you in the next episode.